Hey everyone, and welcome to the Lab Code Chronicles, a podcast where we talk about our experiences in the chemistry world. I'm Joseph.
And I'm Yasmine. Today, we're diving deep into one of the most memorable courses we've ever taken Chem 225 Organic Structure Determination.
Memorable is one word for it. How about the course that turned us into organic detectives?
That's perfect. It's like the Sherlock Holmes of chemistry.
So let's set the scene. The semester begins, and Dr. Kaafarani lays out the grand mission. We're given three vials, just unknowns. No labels, no hints. Just figure it out yourself.
Not going to lie, it's terrifying and thrilling. You have these solids and liquids, and your entire goal is to unmask them. No direct path to follow. You have to know which procedure to take from A to Z.
Exactly. That's the first major upside. This isn't just a cookbook lab. You start with the basics, melting point, getting the boiling point solubility, then you move to a test called the sodium fusion test to see if there's nitrogen, sulfur, halogens, and so on.
And I remember looking across the bench at you during that first functional group test, and I'd be holding my test tube up to the light, looking for a color change, and I see you doing the same thing. We'd just give each other a note like, yep, my unknown is also an aldehyde. It was a shared struggle.
Yeah, it was a shared, enjoyable struggle actually. It forces you to think. You can't just go through the motions. You have to prepare your pre-lab. Have a game plan. So if it's soluble in base, it's probably carboxylic acid. If not, let's try this test.
And then comes the big guns, IR and NMR. This is where the puzzle really starts to come together. You get this beautiful complex IR spectrum with all these peaks, and you're flipping through your notes, matching functional groups.
But the real magic, the moment you'll remember for the rest of your life, is with the H1 NMR. You get that printout and it's just a forest of peaks. You have to count the protons, look at the splitting patterns, any chemical shifts, and here the big picture starts to get clearer.
That's the peak of the detective work. You have a list of possibilities from your chemical tests, and you're using all these tests to eliminate them one by one. I will never forget the moment I finally pieced it together for my first unknown. I was looking at the spectrum, then at my proposed structure, back at the spectrum, and it just fit.
But let's be real, the path to that I got it moment was never straight. Remember the derivative synthesis, for example?
Oh, don't remind me. You think you nailed the structure. So you go to the Schreiner book to prepare a solid derivative for the final confirmation. The book makes it sound so straightforward. But my first attempt, nothing. No crystals, just a sad, cloudy solution.
I had that too. Or even worse, you'd get this uncrystallizable oil. You'd be scratching at the flask with your spatula, trying to get it to solidify, heating and cooling it, and just praying for crystals to form. I must have attempted the same procedure over and over for at least one of my unknowns.
Exactly. And that's where the real problem solving kicked in. It wasn't just about the chemistry in the book, it was about troubleshooting in the lab. What did I do wrong? Did I contaminate it? Did I add the reagent too fast? You'd have to go back, repurify your starting material, and try again with a slightly different workup.
But when it finally worked, when you saw those beautiful sharp crystals from after recrystallization, and you measured the melting point, and it was so dead on with the literature value.
That is the magic moment, and it was earned. It wasn't just given to us. We fought for that melting point.
Yeah, just when you think you've got it all figured out, they throw you the mixture. Now it's not one unknown, it's two plus a solvent, all mixed together.
This is where the real organic synthesis skills kick in. You have to separate them using acid-based extraction. It's like performing a surgery on your solution. You go to the organic layer, you go to the aqueous layer.
And you have to be so careful. One wrong move and you've lost your compound. I remember when we both hunched over our separate funnels, carefully draining layers, making sure we didn't lose a single drop. It's stressful, but again, you're thinking on your feet.
And then you have to identify the solvent on top of everything else. Simple distillation, more tests. It's a marathon. But by this point, you have a process. You're a seasoned detective. You have your tools. You have your methods. We have to give a huge shout out to the people who made this chaos manageable. Miss Riham, our lab instructor, was an absolute lifesaver.
Absolutely. She wouldn't give us the answer, but she'd point us in the right direction. So she would ask us, have you considered this test? Or what does that solubility tell you? She guided our thinking without doing it for us.
And Miss Nairi, always there with a smile, ready to provide any missing reagent or help us with an instrument issue. Knowing that support was there gave us the confidence to tackle these big problems.
This course, more than any other, taught us how to think like chemists. It's not about memorizing reactions, it's about problem solving. It's about using a full toolkit, from simple melting point apparatus to a $500,000 NMR, to answer a fundamental question: what is this unknown?
And that's a skill we will carry forever, whether we go to grad school, work in industry, or just look at the world in a more analytical way. It's frustrating, it's challenging, but it is incredibly rewarding.
So, if you're ever given the chance to be an organic detective, to take a course like Chem 225, embrace the chaos.
Come prepared, think critically, and don't be afraid to get stuck, because the moment you finally crack the case, it's unforgettable.
Thanks for listening to the Lab Coat Chronicle.